Lecture 3 of 4, subtopic 5.2, composite functions. Learning outcomes. At the end of the lesson, students should be able to represent a composite function by using an arrow diagram. Students should be able to find the composite function and also find one of the functions when the composite and the other functions are. Composite functions are functions that arise as a result of the combination of two or more basic functions. The resulting composite functions is denoted as g of f, which is g of f is equal to g of x. The notation g of f is read as g circle f, g round f, g composed with f, g after f, g following f, or g of f or g on f. Example 16. Given that elements of set A, B, and C are defined as A, B, and C, if f is A to B and G is B to C, where fx equal to cert x plus 1 and gx equal to x squared, represent the composite function gfx by using arrow diagram. Hence, find gfx. So I'm going to draw an arrow diagram since we have three different elements A, B, and C. So we're going to have three different circles, and for A, I'm going to write down all the elements in A, which is -3, -2, -1, 3, and 8. For B, 0, 1, 2, 3, 4. C, 0, 1, 2, 4, 9, 12. Since f is A to B and fx equal to cert x plus 1, so fx is equal to cert x plus 1, so I'm going to substitute all of the elements in A. For example, when A equals to -3, I'm going to substitute -3 in here, and then I will get math error. Next, f -2, so I'm going to have -2 plus 1, also math error. F -1, -1 plus 1 is equal to 0. So -1 here can be mapped to 0. Next, f3, so 3 plus 1, 2, so 3 mapped to 2. And then the last one, f8, is 8 plus 1 is equal to 3. So 8 mapped to 3. Next, G is B to C, where G x is equal to x squared. I'm going to do the same thing. I'm going to substitute G 0. So I have 0 square, which is 0. So 0 mapped to 0. And then G2, 2 square, which is 4. So 2 mapped to 4. And the last value is 3. So G3 equal to 3 square, 9. So 3 mapped to 9. So gfx is all the elements in C that is mapped from B and A. So gfx is equal to 0, 4, and 9. Finding the composite functions. In order to find the composite functions, we need to identify the outer and the inner functions, and then take the inner function and substitute into the outer function, and then simplify if necessary. Example 17. If fx equal to x squared, gx equal to 1 plus x, and hx equal to cert x, find fgx. So we are going to take the inner function, which is g, 1 plus x, and then substitute 1 plus x into the outer function, which is f. So 1 plus x here must be substituted into the x. here. So it's going to be 1 plus x square. B, g f(x). Take the inner function, which is f(x), x square. Then substitute x square into g, which is into dx. So 1 plus x square. C, f square x. F square x is the same with f(x). So we write down the inner function, which is f(x). And then substitute x square here into the x. So x square square, x to the power of 4. And the last one, fg(hx), write down the most inner function, which is hx, set x, and then substitute set x into g. Set x here, substitute into g, which is into the x. So 1 plus set x, and then we still have f here, and then take the whole thing here and substitute into the f. 1 plus set x square. Example 18. If fx equal to gx, gx equal to 2x minus 1, and hx equal to x square, find gf3. So we need to find f3 first. So f3 is equal to, substitute 3 into the x. So it's going to be 9. And then we need to find g9. So g9 is just simply substitute 9 into g. So 2, 9 minus 1, 17. So gf3 is equal to 17. Next, bfgh2. Find h2 first. h2, substitute 2 into the x, 2 square, which is 4. And then find g4. g4 is just simply substitute x equal to 4, which is 7. And then find f7. So substitute x here with 7, 21. So fgh2 is equals 21. And the last one, ghf4, we do the same thing. Find f4 first. Substitute x as 4, which is 12. And then substitute 12 into h, which is into the x. So 12 square, 144. And the last one, substitute h f4 into g. So g 144. So g substitute into the x. 2, 144 minus 1, which is 287. So g h f4 is equal to 287. Next, composite function. Determine the inner function. In order to find the inner function, we are going to write down the composite function. For the left hand side, substitute inner function into the outer function, and then simplify to find the inner function. So the first step is to write down the composite function, which is g f(x) equals 2 over x. Next, substitute, for the left hand side, substitute the inner function into the outer function. So f(x) here, substitute into g, which is into the x. So it's going to be f(x) minus 1 square root equals 2 over x. And then the third step is to simplify to find the inner function. Since we need to find f(x), so rearrange until we have f(x) as a subject. So square f(x) equal to 2 over x square plus 1. And then simplify fx equals to 4 over x squared plus 1. Next, composite function. Determine the outer function. To find the outer function, we need to write down the composite function, assume the inner function as u and the outer function as fu. Change fu to fx and then simplify the function. So the first step is to write down the composite function, which is ftx. 2x plus 1, and then substitute write down g, which is 2x plus 1. And then the next step is to assume the inner function as u. So the inner function, which is gx, I'm going to assume as u. Let 2x plus 1 equals to u, and then rearrange until you have x as a subject. So from here, instead of f to x plus 1, it is now fu, and then all the x here, substitute with u minus 1 over 2. Right, and then the next step is to change fu to fx. Just simply change from fu to fx. And we're done. I'm sorry. It's supposed to be x. Change all the u into the x. As simple as that. And then the last step is to simplify the function. 4 x squared minus 2x plus 1 over 4. This one can be cancelled out, so just x minus 1 plus 1. And then 4 can be cancelled out, so x squared minus 2x plus 1 minus x plus 1 plus 1. So x squared minus 3x plus 3. Subtopic 5.4, exponential and logarithmic function. Learning outcomes. At the end of the lesson, students should be able to find the composite functions involving exponential and logarithmic function. Composite functions, exponential and logarithmic functions. Perform the composite functions involving exponential and logarithmic function. Example 21. Given fx equal to ln x and gx equal to e to the power of 3x, determine g of f. G of f is the same thing with g of x. So in order to find g of x, we substitute fx, which is ln 2x, and then take the whole thing here and substitute into the x. E3 ln 2x. And then we know that e and ln can be simplified into e ln 2x cubed, and it's just 2x cubed, which is 8x cubed. B, f of g, which is f gx. Substitute g, e to the power of 3x, and then e 3x, substitute into the f, ln 2e 3x. Next, C. Find hx if hg equals to x squared. So this is the composite function, hgx equal to x squared, and the unknown function is the outer function. We don't know the outer function. So if we don't know the outer function, we need to substitute our gx, which is e to the power of 3x, and make it equal to x squared, and then let let e to the power of 3x equals to u. Getting here, let it equal to u, and then rearrange until we have x as a subject. Ln u over 3. And then substitute. So now it's going to become hu, and x here, substitute with ln u over 3, so square. And then change u to x. And we're done. Next, for the last example, D, we are given GHX equals x plus 2, and we need to find the inner function. The unknown function is the inner function. So if we don't know the inner function, we're just going to substitute hx into g, which is into the x. It's going to be e, and then 3, just x here, substitute with hx, x plus 2, and then rearrange until we have hx as a subject.